This is a Queen Mary's College video on the hydrolysis of esters, so you'll need to be looking at page 18 in your knowledge pack. That's the What's in Medicine knowledge pack, section 5.1. So first of all, we're just going to recap the esterification reaction, so the making of an ester. Just a quick recap there. So as you know, we start with a carboxylic acid, react it with an alcohol, and we form the ester and water. So the hydrolysis of esters is really just the reverse of this reaction, so called reverse esterification. So we break down the ester by reacting it with water. So here's the ester, ethyl ethanoate. So reacting it with water, and the products would be the carboxylic acid first of all, and the alcohol. So we get the carboxylic acid and the alcohol back again as products. Here's an animation showing the water molecule. Breaking up the water molecule, the OH group goes to the carboxylic acid, and the hydrogen forms a new bond with the oxygen of the alcohol. So you can see that water molecule broken down to reform the carboxylic acid functional group and reform the primary alcohol functional group. The catalyst for that is dilute sulfuric acid, dilute so that it provides extra water to ensure plenty of the products. So there you can see the formation of the carboxylic acid and the alcohol there. The second way of bringing about this hydrolysis or reverse esterification is using an alkaline. So again, starting with the ester. This time we're reacting it with sodium hydroxide, a typical alkaline. And we get back the alcohol. And instead of the carboxylic acid, we get the carboxylate salt. So in this case, ethyl ethanoate ester with alkali produces the ethanoate ion, sodium ethanoate. So you can see the sodium hydroxide, the alkaline hydrolysis, reforming the alcohol group, and instead of the carboxylic acid, we get the sodium carboxylate salt, in this case sodium ethanoate. So the second type of reverse esterification hydrolysis using an alkali like sodium hydroxide, we get the carboxylate salt and the alcohol, but not the carboxylic acid. It is useful to bring about the conversion of the carboxylate salt to the carboxylic acid. So that can be done simply by adding a strong acid like hydrochloric acid. So adding for acidifying with HCl will convert the salt, the sodium carboxylate, to the carboxylic acid.